All right, get your homework out.
You did it?
Aiden, where you at? All right, quiet please. Any questions on the, well, we had 2 homeworks we got to turn in, right? We're going to go over this one, 4.5 in class, all right? Any questions on homework 4.5? 4.5. My book's right there.
I have a question.
All right, everybody quiet so I can hear the question. Go for it.
I need staplers. That's a statement. Can I borrow a stapler? That's a
It's over there. All right, hey, let's settle down. Settle down. All right, no questions, really? Period 1 had lots of questions. They were a little lost. Student advisor. Get me up to student advisor. Okay, check your work. I'm going to call out the answers. Here we go. Questions 1 through 6. I hope you got these. All right. We're going to do the one that I assigned yesterday, but we're going to collect both 4.4 and 4.5 today. Here we go. Number 1 is a pentagon. Number 2 is a quadrilateral. If you put a type of quadrilateral, okay, I'll accept that. But just remember, if all they say there's 4 sides, how do you know it's a parallelogram? How do you know it's a trapezoid? You don't, unless you see the shape. But if it's got 4 sides, the only thing you can be sure of is that it's a quadrilateral. Yes. Quadrilateral. But question number 1 was pentagon. Question number 2 is quadrilateral. If it has 4 sides, it's not a pentagon. Okay. Number 3 is a hexagon. Number 4 is a decagon. Number 3 is a triangle. Number 5 is a triangle, sorry. And number 6 is an octagon. All right, number 7. Regular means all the sides and the angles are the same measurement. So if you're a regular quadrilateral, you are a square. Number 8, if you are a regular triangle, you are an equilateral triangle. Square. Equilateral, and it is in the notes. Okay. All right, 9 and 10, we're just calculate the perimeter. Now, there's no units, so you put the word units when there's not units. So number 9 is 14.1 units. Number 10 is 14.7 units. Number 17. If it's a pentagon, it's got 5 sides. It also has 5 angles. So if all of them added together is 540, this is the question. Well, then that means each of them divided by 5, you get 108 degrees. So 17 through 24 are all basically this question. Number 18 is 120 degrees. Number 19 is 2.56 meters. Number 20 is 1.38 kilometers. Number 21 is 12 meters. 22 is 25.6 centimeters. 22. 23 was the one that gave period 1 problem. So it said diagonals of a hexagon. Diagonals of a hexagon. So if I have a hexagon and I draw its diagonals, it's talking about unique ones. So if I start at this vertex right here, I can draw 1, 2, 3. Technically, you can draw 3 from every single one. But as soon as we get to this one, when we draw this one, it's the same one. So if we just think about unique ones, Well, that's 3. If I go from here, 4, 5, 6. I'm going to run out of colors here. I'm out of color, sorry. 4, 5, 6, 4, 5, 6, 7, 8, 9. There's only 9 unique ones. 9 unique ones on 23. But, I mean, technically you can draw, I know a lot of kids were putting there's 18 of them, and I understand why, because they're like, well, you can draw 8 or 3 from each vertex. But there wouldn't be unique. I mean, this one goes to here, this one goes to here. It's the same one. Oh, I gave you the answer to 24. I'm sorry. These are not the droids you're looking for. 23 is how many can you draw from one vertex? That is 3. Thank you. I'll give you a point for that. And then number 24 is the one that I just drew on the board. It's no. All right. Make sure your names are on that. Okay. And I need 2 homeworks. 2 homeworks from you. 4, 4, and 4, 5. 4, 4, and 4, 5. Another day of definitions.
Yay, how fun.
All right, look at the calendar while they're passing out and collecting. We have no quizzes or tests the rest of this week. Listen, please. Here is your homework. Here is your homework. There's not much. That must mean they're a little complicated. We will get 2 formulas today. 2 formulas. Remember, on all tests and quizzes that I give, you are allowed to bring in a resource card, a sheet of paper with anything written on it. If you show up for test day and you can't remember this formula or how to use it, shame on you. You didn't prepare for the test. The nice thing that you can always count on from my class is that you don't have to memorize formulas, but you do need to know how to use them, and you do need to make sure if you don't have them memorized, they're on your resource card. I will never give you a formula during a test. If you can't remember it, this is easy. This chapter only has these 2 formulas. When we get to the next geometry chapter, it won't be the next one, but it'll be 3rd quarter-ish. There will be, I think, 14 formulas to memorize, and that's just way too many. So you can put them on a resource card. Anything else? Now you're doing this in a pattern this time, right? Yeah. Okay. Thank you. All right. So today's lots of definitions. I would say that some of you know some of this, but none of you know all of this stuff. Okay? So you're going to need to take good notes. Here we go. Circles. Circles is what we're doing. Circles are not polygons. Remember, polygons are made up of segments joined at their endpoints. Circles are not made up of segments. Lots of objectives, so lots of things to write down. Here we go. New vocabulary question mark, because some of these you will know, but some of this you won't know. All right. To draw a circle, you must first start with 1 point. We call it the given point. So I will give you this point right here. Wait, come back here. I will give you that point right there. All right. You take that point and a ruler and a specific distance. You get to make up the distance. Let's say 10 centimeters. I put my ruler on the point. I measure across 10 centimeters and I make a line. I don't. I make another point. I take my ruler. What was the distance?
10 centimeters.
I measure to the left this time, 10 centimeters, and I put a, okay, this is where you're supposed to be paying attention. I take my ruler and I measure what? 10 centimeters straight down, and I put a, I take my ruler and I measure 10 centimeters straight up, and I put a, what would happen if I didn't do it 4 times, but I did it 5, 6, 7, an infinite amount of times? What would I make? That's where we get our definition of a circle. So what's the definition of a circle? What did I just do? How many dots? And how did I measure the dots? From the, that's the definition of a circle. Who can make that into a complete sentence? What?
The definition of a circle is many points combined to make one.
Yeah, but you got to say everything that I did there. What did I do?
You made a starting point and then you put dots around.
Okay. The definition of a circle is this. It is the set, that's fancy words for the collection, of not one point, but all the points that are the same distance away from a given point. And this should say on a flat surface or a plane. The book doesn't use that, but man, it needs to say on a plane. Because if it's not on a plane, you made a basketball, a sphere. You have all the points that are at distance. Well, that would also include 10 centimeters straight out. You have all of that, you make a 3-dimensional object. So our book doesn't put in the words on a plane, but they should be on a plane. What is the shape of a circle? We can't use the word circle. Sphere, not a circle.
A shape with a lot of dots in it.
You can't use the word circle, but I like where you're going with this. Okay, maybe we might use the word round or curved, right? There are no segments here. It's not a polygon. It's not made with segments, right? Second thing, and maybe you've never realized it before, but am I touching the circle? Am I touching the circle? Am I touching the circle?
Yes.
So when you make a circle, it should be, well, a flat hula hoop. It's not the middle part. If you include the middle part, what's the shape? No, sphere's 3 dimensions. A circle is just a block.
A big point.
If I include the center of a circle, what is the shape? And it's not a circle.
A donut.
A sphere is 3 dimensions. This would not be 3 dimensions. I said include the center, so
A diameter.
okay, this would be called a DISC, a disc. A disc is the circle in the middle.
That makes so much
So when you make a circle, it doesn't include the middle. Even though if you look on the paper, a lot of times, myself included, when I make a circle, I shade the center. I don't want you to think that the center is included in a circle. It's not. It's not even part of the circle. Okay? How do you name circles?
By the center point.
You name circles by the dot that you use, the point that you use to create it. Remember, the definition is a collection of points a given distance away from, a set distance away from a given point. So this point is what defines a circle. Paradoxically, it's not part of the circle, how you make the circle. But this dot right here is not part of the circle. So even though we're going to call this circle circle A is not in the circle. It's on the disc, but it's not on the circle. So we will name this circle A. We have a symbol. Does anybody know your astronomy symbols? What's the astronomical symbol for the sun? Okay, I'm not talking astrology, I'm talking astronomy. So for instance, the Earth, anybody know?
Circle.
There's the Earth. Anybody know Mars?
One with one line.
Anybody know Venus?
Is it down?
Stick there without the legs.
Yeah, guess why it's called the girl symbol? Because it's Venus. Guess why that's the boy symbol?
Because it's Mars.
Because it's Mars. Right? There are astronomical symbols for not astrology. That's fake stuff. But astronomy uses symbols for all the planets. All right. The astronomical symbol for the sun is also the same one for circles, and it is a circle with a dot. That's the symbol for math for circle. You'll see this tonight. Circle A. Pretty easy, yes? All right. So this is circle Z. Pretty simple. All right, box 2A, draw this. We're going to write one little definition off to the side. 2A, draw it. Draw it, yep. Remember, the yellow is not part of the circle. It's part of the disc, not part of the circle. All right, on your circle, I want you to put 2 points. On the circle. So where am I asking you to draw this? On the black portion. Give me 2 points, not 1, 2 points. Doesn't matter. Mine are there and there. Nothing special about where I put them. They're on the circle. Yes? Jake, I know you're trying to finish the homework from last night, but I need you to pay attention for tonight as well, too. All right. If you have 2 points on a circle and you play connect the dots, you have made a, anybody know?
Chord.
Anybody know?
Diameter.
Okay, a couple people do know. You have made what in math we call a C-H-O-R-D, a chord. So the definition of a chord is exactly what you just made. The segment that joins 2 points that lie on a circle. They have to be on the circle. If I connect B to Z, Z is not on the circle. Yes.
Are we writing
All in 2A, yes. I said, and this is it. There's nothing else. Chord. Now, clearly a couple of you have been exposed to this before. Some of you remembered it. You guys have all been in the same class for the last 3 years. Some of you don't, right? 7th grade is where you got to know this. Right? Jay, start working.
I'm measuring this.
Well, there's nothing to measure today.
Not measuring. Making this.
Okay. All right, so that's a chord. A chord is what shape, basically? It's not a line. A chord is absolutely 100% not a circle. What shape is a chord? It's not a line. A line goes on forever. It is a segment. So how do we name chords if it's a segment? By the endpoint. So since a chord is a segment, this is chord what? This is chord AB or BA, right? So is this one. Quick note, in the book, on the paper in front of you, mathematicians always get a little efficient or lazy, however you want to describe it. Technically, or usually we do not put the points on the circle. It just makes the diagram too complicated. So when you see this, there's a point there. We just choose not to make it a nice big fat point. Okay, it's there. Okay, if you see a letter next to it and it's capitalized, there's a point there. Okay, occasionally I'll get kids like, well, there wasn't a dot there. I didn't think there was a point. So here's your example. Notice there's no dot here. There's a dot in the center. Nathan, how many chords do you see? Name them. Say what? Say what? F. Chord FG. Go. Keep going. Okay, that's the same chord. Okay, so how many chords did you actually see? You just named 2, my friend. He said F, G, G, F, and I said that's the same chord. E is a point. Okay, read me the definition of chord. What does it say? Read the definition of chord. It's in box what? 2A. Nathan, can you read it? You didn't write it down. Is X on the circle or off of the circle? So the definition of a chord is a segment whose endpoints are on a circle. X is not on the circle. EX is not a chord. So how many chords are there? There's 2, right? FG, or if you want to call it GF, that's the same chord, and AC or CA. Those are your chords. So on circle X, there are 2 chords. You're like, wait, there's 4. Yeah, because AC could also be written CA. Is that point clear? All right. Anybody know what EX actually is? Okay. So we're going to learn something today. All right. In box 2B, now it's your chance. Write down all the chords that you see. In 2B, take about 10 seconds. You don't need to write it down 2 different ways, right? If you think XY is a chord, then you don't have to write also YX. We'll talk about that here in a little bit. If it meets the definition of chord, then it's a chord. We done? Jake, what are the chords that you see in box 2B?
A, B, and D, E.
How come CX is not a chord? This was Macy's question. Why is CX not a chord?
Because X isn't connected to the circle.
X is not on the circle. For it to be a chord, both points need to be on the circle. CX is something we'll talk about here in a little bit. All right. I guess that's worthy of applause. Right? All right. So he named all the chords. Very good. All right. Here are 2 unnamed points. Are they on or off the circle?
On.
So if I connect them, what do I make? I make a chord, right? So I'm going to make the chord right there. What do you notice about this chord? It goes right through the center of the circle. Therefore, this chord, it is a chord, gets a special name. You probably already know. It is called a diameter. Okay, from the Greek diametros, right? Diametros means to measure across. It doesn't mean to something. Diameter is how we pronounce it, is a chord. Why? Because the 2 endpoints are on the circle. What's special about this chord is that it goes to the center. So we give it a special name. So what it measures is the widest part of the circle measured from its 2 points that are on its surface. You should not have made it to 7th grade without being exposed to the word diameter. Now, since it is a chord, we also name it the same way we name a segment. You don't need to write from the Greek diametros, but there's an equal number of Greek and Latin words in math. If it's geometry, a lot of times you'll see lots of Greek, because the Greeks were the really, really, really into geometry. Yes? It absolutely looks like a Pokemon ball, which is why I won't make it red and white, because then I'll have too much people talking about things. All right. Let's see. It says name the circle. This is circle. This is circle M. It says name the diameter. That's the diameter is LK or KL. Okay. In box, what are we on? 3B. Name the diameter. Should take you 5 seconds. Go. The diameter. It says plural. That's just to try to trick you. There can be more than one, but how many diameters does this particular drawing have? Just one. Now there could be more. I mean, if I connected C to A, we would get another one, but in this case, they're not connected. So I only have one. That diameter is either one. Okay. All right. Okay, a diameter is a chord that goes through the center. Does AB go through the center? No. All right, more vocabulary. Take a guess what I'm going to ask you.
You're going to ask us about the radius.
If I connect the center to any point on the circle, if I connect the center of the circle to any point on the circle, I have made a plural of radius is, there you go. So radius, plural radii, it's a segment that has one endpoint on the circle, and the other one is the center of the circle, radius. So it basically measures half of a diameter. Okay? 2 radii would make 1 diameter. If you go from the center to a point, that would be half of a diameter. 2 radii make a diameter, half of a diameter make a radii. Any radius that's measured on this circle will have the same measurement. It doesn't change. That's one of those unique things about a circle. Any diameter of the circle has the same measurement, as long as it's the same circle or a congruent circle. Radius, a segment that has one endpoint on the circle and the other is the center of the circle. Remember, the yellow part is not part of it, nor is Z part of the circle. It's the center for sure. That's how you make the circle. You measure from the center outwards. But it's not part of the circle. The circle is just the outside. All right, 4A. So you go, one quick note about, it's the only one you got to be careful about, radius. So the note is, the radius, when you label it, are you listening? It starts from the center outward. It starts from the center outward. It starts from the center outward. Why am I saying it 4 times? Because kids miss this all the time. So here's mine. Let's see. I have 3 radii here. It says you got to start from the center outward. So I have radius GB, I have radius GE, and I have radius GD. Okay? All of those are radii. GE, GD. Notice they all start with the letter G. Why G? G is the center of the circle. Hey, if GE is 10 centimeters, how big is GD? How big is GB? They're all 10. You can say the same thing about diameters. If one's 10, they're all 10. Okay? It's not that the measurement changes. It stays the same. One more time. Name the radii. Write it down. Question, or you give me an answer? Okay. So you're asking me a question? Okay, what's the question?
Oh, wait, no.
Yeah, no, I don't want you to call it out. We good? Maddie, give me the radii. Starts at the center. Where is the center? And what's the name of that? No, literally, what's the name of the center? On this circle, what's the name? You're making it way too complicated. Where's the center? What's its name? X. So radii measure from the center to the circle. So radius, in this case, X. So radius X. You start from the center and you go to a point. XB or X or X. Why not XA? There's no black line there. If there was one, XA would be one. So we have 3 radii here. They all start with the letter X, because X is the center. Maddie, yes or no? Don't say yes if you mean no.
I have no idea.
Do you know what a radius is? Can you read your notes? Read it. Somebody help her out. Read your definition of radius. Go.
A segment
A segment. You go.
that has one endpoint on the circle.
On the circle, and the other one is the center.
The center of the
The only thing you got to add is that it has to be from the center outward when you name it. Who's lost on radius? Abby, if you're still lost, Maddie, if you're still lost on radius, student advisement, call me over. We'll do a bunch together. All right. So here we go. We'll start with Soraya. We're going to go back row, straight across. Soraya, name it. This is box 5. Okay, circle B. What's the symbol look like? Circle with a dot in the center. Okay? All right. Jake. Read it and answer. DE is a chord. Why is it a chord? It has two endpoints on the circle. Why is it not a diameter? It doesn't go through the middle. DE. Any other ones? Nope. DE and FG. Good job. All right. Say again. Didn't say that. It says, read what it says. Are there other chords there? Absolutely, but those will be diameters. All right, read it. Now do it. He's putting on his magic glasses. BA, BD, BC, BG. Very good. Yes? All right, read it. Read it. Good? Yes? All right. So, homework occasion will look like this. They'll give you some weird looking shape and then they'll have a bunch of questions. That is absolutely a kite, right? It also is equilateral triangles and obtuse triangles and anything else there?
Yeah, the circle is not a real circle.
It's
really weird.
All right. On your own, box 6. Give me the names of all the chords. Give me the names of all the diameters. Give me the names of all the radii. All the chords, all the diameters, all the radii. Box 6.
Can a chord be a diameter?
A chord can be a diameter, absolutely.
I'm done. Okay, so
Diameters are always chords, but not all chords are diameters.
I'm done.
And that's about how long it should take you.
2.2. I do so good in class when it gets in the homework.
So that's why you do it on this sheet of paper. You keep it so that you have your notes.
I know, I do, and then I use it.
Okay, good.
And then I throw it away after I test.
Not from the middle, that's the radius. Diameter is a chord that goes through the center. All right, Richard, give me all the chords. All of them.
Isn't it just like BC, BA, AD, and DC?
BC, keep going.
BA, AD, and DC.
You got all the chords. What did he miss?
Nothing?
He missed the diameter. Remember, all diameters are chords. Okay, so he missed AC. All right, who are we on? Sam, give me the radii.
D,
We always start radii from the center.
okay,
OD, OB, OA. Very good. All right, you tell me, is that an easy or hard skill as the things we just did? As long as you have your definitions in case you don't have them memorized. If this was all new to you, some of you might be slightly confused. You might have to go back to your definitions. But on a scale of 1 being ridiculously easy, 10 being ridiculously hard, this is closer to 1, right? All right. We're moving on. We got more stuff. Flip the paper over. All right. If we measure the distance around a circle, we are actually measuring a perimeter, yes?
Yeah.
We measured a perimeter on polygons last night for homework. Well, I don't know why, but somebody made up, we're going to give it a special name. It's perimeter. It is absolutely 100% you're calculating the perimeter. So if we measure the distance around a circle, how in the world do we do that? It's curved. Well, I'll give you a couple of ways. If you have a circle, right? The bottom of this is a circle, yes? You could put a mark, right? Right here. I could put it on a flat surface, transfer that mark and then roll it, right? I would make a what shape as I'm rolling it? I'd make a line, right? If I take that and I roll this out, I'm making a line where it touches the flat surface, right? Sort of, but I'm not rolling. I'm only seeing how far it goes, okay? It's like what would it trace on the bottom? The second way is to get a string, wrap it around, and then lay it straight and put it next to a ruler. That could be one way to measure the circumference. All of that sounds absolutely complicated. If we're a math classroom, do I want you to carry around string, that sort of stuff? Okay. So there must be a different way of measuring it. There is. It is a formula. So for the next 5 minutes, we're going to be talking about this formula. So first thing we have to do is we have to write down the word for perimeter. Circles are special. They get special names, right? We don't call it a segment. We now call it a chord. We don't call it the perimeter. We call it the circumference. It's the distance. It's the perimeter of a circle. Circumference is Latin. It comes from circum, and it just means around. Well, yeah, that's the bad math teacher that names their kids with math terms, but no, I didn't give my kids math terms. I might name my dog a math term. I hadn't thought about that, but no, I wouldn't name my kids this. All right.
Name it triangle.
Right. All right, write this down, please. Circumference. You don't have to write the Latin part. Circumference is the distance around a circle. Now, I showed you two ways of measuring that. They were both complicated. They both required physical objects, rulers, whatnot. We do have a formula. I'm going to show you this is the first time, 7th grade, when you get to learn where a formula comes from. Up to now, teachers basically said, this is the formula, write it down, use it. Now I'm going to show you where the formula comes from. Okay. All right, we good on circumference? All right, so it turns out that when ancient civilizations first looked at this problem, how do you measure a circle, right? They did it the way exactly what I just did. They wanted to find a formula. Well, they found something interesting. What they found was this, that if you measure, and this works for any circle, not just some, but for any circle. If you actually measure the circumference, the way I showed you, with a string, or roll it on a flat surface, mark where it starts and where it finishes. If you measure any circumference, and you measure its diameter, and you divide those two numbers. This is for any circle. This literally was earth-shaking for ancient humans. Because when you do this, when you take any circumference, any, and you divide, now it has to be for a specific circle, and you divide it by its diameter, guess what happens? Not once, not twice, every time. You can use it for this circle. You can use it for the circle on the clock. In Switzerland, they have this humongous circle that's miles wide, right? It's called CERN, right? If you measure that circle and you take its circumference and you divide it by diameter, guess what number you get every time?
0.
You get that number.
Every time.
And that's why it caused problems. They literally thought this was a magic number, literally, because anytime you do this, you get that number. It works for all circles, not just one. Obviously, this number is the number we know as, and I put ... because it goes on forever. Also, it never stops. That's why they also thought it was magical, because no matter how accurately they measured, they kept getting different numbers, and it just continued. They never got to a repeating decimal. They never got to a terminating decimal. It just went on forever. Never repeated and never stopped. That number is what we know as this symbol. Oh, by the way, if you are in Greece and you are in kindergarten, when you get to the letter P, guess what you say? It's their Greek letter P. It's not a made-up thing. It's their alphabet. This is the letter P in Greek, right? So if your name is Peter in Greek, that's the first letter of your name. All right. So listen up, listen up, listen up. Okay, so once again, it turns out that if you take any circle, measure its circumference, divide it by its diameter, you get pi. 3.1415926, and it doesn't stop ever.
Do you make that?
No. We can make this into a formula. Instead of writing the word circumference too long to write, I'm going to write the letter C. Instead of writing the word diameter too long to write, I'm going to put lowercase d. Pi is, well, it's p, right? We know some algebra now. If I want to solve for circumference, what's attached to C? How is the d attached to C? How do we get rid of division in algebra? We multiply both sides by d. d divided by d cancels, and you're left with C equals pi times d. That is the formula for circumference. D is the diameter. It depends what circle it is. Every circle has a different diameter. Every circle has a different circumference. But every single circle has the same pi. It's called constant. It never changes. This is the formula that we will use tonight for homework. Write this down, 7b. Write this down, please. The formula for circumference is pi times the diameter. Except we don't want to write diameter, so we put C is equal to pi d. C is equal to pi d. We got a problem, though. A diameter is 2 radii. So we can also, now here comes the confusing part. It's just pi times d. That's it. Pi is 3.14. You multiply 3.14 times the diameter, you're done. There's nothing to be confused about there. Okay? But it turns out that math books do make it confusing because they give you a second formula. You ready? How many radii make up one diameter? So I can write this as 2 times the radius because 2 radii make one diameter. When you open up your book tonight, they're going to show you 2 formulas. Circumference equals pi d or circumference equals 2 pi r. How many formulas do you actually need? You only need one. I hate this formula right here, 2 pi r. You want to know why? Can anybody tell me what the area of a circle is?
360.
It's got a pi, it's got an r, and it's got a 2, just like that formula. Area is pi r squared. We'll talk about it in a few chapters. Circumference has a pi, an r, and a 2 as well, too, and students will make a mistake. Sometime between when I was educated and you are being educated, math teachers got smart, and we said, kids are going to be confused by this. So let's forget this formula and let's just use pi d. I would highly recommend that you only use pi d so you're not confused. The book is going to show you 2 pi r. Why? Because 2 radii make one diameter. 2 times r equals d. Hey, Maddie, you're not even trying to pay attention. All right. So the only thing left to do is a few of these. Hey, is that a diameter or radius? That's a diameter. Okay. The diameter of this circle, if we divide it into the circumference, every single time we get this number 3.14. It's called pi. The issue is that number never stops. You can't do math with a number that never stops. So then we round. This is why, at least in 7th grade, do not use a calculator tonight. In 7th grade, we simply say, let's just round it to 2 decimal places. This is why you, write this down, please, box 7C. You will use tonight, for that symbol right there, you will use 3.14. It's not pi. It's not even close to pi in the sense of the decimals keep going on forever. It's close enough to pi for general calculations. 22 over 7, well, it turns out if you take your calculator and divide 22 over 7, you get 3.14. When you deal with problems that involve fractions, for pi, you're going to use 22 over 7. When you don't have any fractions, you're going to use 3.14. And lastly, this. Whenever we round, can we use an equal symbol? What must we use when we round? The approximation symbol, which are 2 wiggles. Okay. So as soon as we change pi symbol into 3.14 or 22/7, we erase the equal sign and we put 2 wiggles. Approximations. Pi is not 3.14, but it's a good approximation. The only thing left to do now is some calculations. I will use both formulas. I highly encourage you to put your calculator away. Notice. I highly encourage you to use pi d, not 2 pi r, but I will show you both. All right, here we go. Hey, radius or diameter?
Diameter.
You ready? Danny, you paying attention? All right, Danny, what's the formula for circumference?
But it's pi.
Okay, you're reading the wrong box. The formula was written in box 7B. What's it say in 7B? Okay, that's you wrote in the wrong boxes. Please write this down, Danny. These are the 2 formulas and highlight them. Those are what you're going to use. The other part was to show you so this doesn't look like magic and then I'm lying to you. The other part was just a demonstration of where this formula comes from. Math is taught this way from now on. You don't trust your math teacher ever. Just because an adult in front of you says, believe me, it's true, you should question them always. Right? Agreed, and I will prove it to you. Right? So in math from now on, this goes for all of your classes, just because someone says it's true, you have the right to say, you need to show me why that's true. This is not a smart aleck. This is not to be used in jest, but it's used in truth. You should be taught truth, not magic. Okay? All right, here's the truth. And oh, by the way, I proved to you where these formulas came from. That was the whole purpose of that. Okay? Well, that's what I'm trying to do right now. Okay? I have a circle with a what? A radius or diameter? So which formula do we want to use? Which one has a d in it? C equals pi d. So I write C equals pi d. You see what I did? If they give you a diameter, I'm going to use the one with the d in it. Okay? Well, I know what pi is. Pi is what? From the previous box. 3.14. I know what the diameter is. The diameter is?
10.
So what does it say to do with those 2 numbers?
Multiply.
So all I'm going to do is multiply. Now, as soon as I put in 3.14, I can't put an equal sign any longer. Now, this formula in yellow turns into this. All I did was take pi and write 3.14. All I did was take the d and write the diameter. The diameter is 10. I multiply those 2 numbers together, put the units, and I'm done. No, we're not going to spend time actually multiplying decimals in class, but we're going to understand what you do with them. Question? I do, but I'm just saying that, we're not going to spend 5 minutes doing that. We're going to say, this is the setup, this is the answer. Yes. You will be doing 6 of these tonight for homework. It's just multiplication. Hey, your last test was on what? Decimal multiplication. So this is an application of decimal multiplication. Hey, can I give you a radius or diameter here?
Radius.
Okay, so which formula uses the radius? So I'm going to write that one. What's pi?
3.18.
What's the radius for this circle?
2.
So all I'm going to do is replace those values with what I know now. Are you with me, Danny? Okay. What's 2 times 2?
4.
So this turns into 4 times 3.14, which I'm going to claim is that number right there. All I did was some multiplication. Other people will think about this a different way. How do you turn a radius into a diameter? How do you turn a radius into a diameter?
Multiply by 2.
Well, then this has a diameter of
4.
So why don't we use this formula and just multiply pi times 4? Either way works. We'll still get to the same answer. For me, I only ever use pi d. This one looks too much like the area formula for me to use. Okay? All right, let's do 3 of them together. Here we go. This is box 9. These are the ones you have on your papers. Here we go. You have 2 formulas. You may use either one of them. The first one on the left, is that a radius or diameter?
Diameter.
That is a diameter, so I'm going to use C is equal to pi d. So I write C is equal to pi d, and then I fill in the right information. Pi is approximately 3.14. D in this case is whatever 5 times 3.14 is the answer, and the units are inches. Questions? 15.7 inches. Second one. Is it a radius or diameter? Stop packing up. Is the second one a radius or diameter? So it's C is equal to pi times d. So C is approximately 3.14 times, what's the diameter here?
2.
Whatever that is the answer. Last one, is that a radius or diameter?
Radius.
So we're going to use C is equal to 2 pi r, or just double it and throw it into pi d, your choice. Okay, so C is equal to approximately 2 times 3.14 times the radius is 3. Or 2 times 3 is 6, 6 times 5. Yes or no?
6.2.
All right, see you guys later. All right, Eleanor, questions? All right. I think you're probably having internet problems. All right. I'll see you guys tomorrow. If you have any questions, just go ahead and send me an email.